Hello everyone, welcome to my video. In this video, I will explain the shortest job first, or the SGF CPU scheduling algorithm. SGF can either preemptive or non-preemptive, but in this video, I will focus on the non-preemptive version. The main idea of SGF is the CPU select the process with the shortest burst time to execute first. Means that this helps reduce the waiting time of a process in the system. To make it easy to understand, let's look at the example. Imagine a printing shop. All customers send their files at the same time, but each file has a different number of pages. The printers print the file with the fewest page first, so job finish faster. Each print job has a different number of pages. The printers always print the job with the fewest pages first. This is the process table. The print job arrival time and the page to print or burst time. The print job has a G1, G2, and G3. And the arrival time is 0. It's because they send the file in the same time. And the page to print or burst time, the G1 has a 6 pages, and G2 has a 2 pages, and G3 has a 4 pages. Gantt chart. A Gantt chart is a visual timeline that shows how processes are scheduled and execute over time in the CPU scheduling. It shows which process is running, when it starts, and when it finish. To better understand how shortest job first or SGF works, consider the 3 print jobs that all arrive at the printing shop at the same time. G1 has 6 pages to print, G2 has 2 pages, and G3 has 4 pages. Since all jobs arrive at the same time, the printer select the job with the fewest pages first. As a result, G2 is the printed first, followed by G3, and finally G1. These orders show in the Gantt chart where G2 runs from time 0 to 2, and G3 from time 2 to 6, and G1 from time 6 to 12. Based on this schedule, G2 has the shortest waiting time, while G1 has the longest waiting time. Calculation. A waiting time is the total time a process waits in the ready queue before it starts executing in a CPU. And the turnaround time is the total time from when a process arrives until it finishes execution. In our example, all print jobs arrive at the same time. G2 is executed first because it has only 2 pages, which is the shortest job. Since G2 starts immediately, its waiting time is 0 milliseconds and its turnaround time is 2 milliseconds. Next is G3 is executed. G3 wait while G2 is being printed. Its waiting time is 2 milliseconds. After printing its 4 pages, G3 finishes at time 6, giving its turnaround time of 6 milliseconds. Lastly is G1 is executed. G1 wait for both G2 and G3 to finish. Its waiting time is 6 milliseconds. G1 complete at time 12, which means its turnaround time is 12 milliseconds. This example shows how shortest job first scheduling works by completing shortest job first, which help reduce waiting time. This is the key term of the shortest job first. First one is process, a program waiting to be executed by the CPU. Second is burst time, the amount of CPU time a process needs to complete. Arrival time, the time a process entered the ready queue. Waiting time, the total time a process waits before execution. Turnaround time, the total time from arrival to completion. Completion time, the time when a process finishes execution. Ready queue, a list of processes waiting for the CPU time. Gantt chart, a lifetime showing the order of a process's execution. We are here in the advantages, disadvantages, and best used when. In the advantages, minimize average waiting time, efficient for batch system, simple to understand. And the disadvantages: required knowing burst time in advance can cause starvation for longer processes. And best used when the burst time unpredictable, system focuses on the minimizing waiting time. So, one major advantages of shortest job first algorithm is that it's produced the minimum average waiting time compared to other scheduling method. It is efficient and works well in a batch process system where job length are known in advance. However, a key disadvantages of SGF is that it required prior knowledge of burst times, which is not always possible in a real system. Additionally, longer processes may suffer from starvation if shorter jobs keep arriving, causing delay in execution. The shortest job first scheduling algorithm improves system efficiency by prioritizing processes with shorter burst time. Compared to the first come first serve, SGF significantly reduces average waiting time because it does not simply execute processes in arrival order. While FCFS is easier to implement and fair in terms of arrival, it can lead to longer waiting times, especially when long processes arrive first. Overall, SGF offers better performance but at the cost of fairness and practicality. And that's all for my videos about shorter job first scheduling algorithm. Thank you.